Welcome to the Phantom Woodworker Project Video Series. In this project videotape, we will build this beautiful coat rack. It features simple lines, 3 graceful legs, rope molding, circular accent cuts, and classic brass hooks. We've also added fine details such as pocket milled reliefs for the brass hooks and the legs. The 3 legs are joined with dovetails. The post was built in 2 sections and joined together using a dowel screw. Of course, it could have been built in one piece using the 80-inch upgrade. Remember, safety first. Always wear eye, dust, and ear protection when in the shop, and follow the safety instructions supplied with the power tools you purchase. To complete this project, we used 5 different router bits. We will begin by looking at the bits used for stock removal. There are 3 choices: a spiral 2-flute bit, a more common straight 2-flute bit, and a center cutting surface planer bit. We chose a dish cutting surface planer, and as you can see, this bit cuts on the bottom edge for a smooth finished surface. Next, we used a point cutting round over bit with a 3/8 inch diameter radius. This bit was used to cut the rope molding. For the circular accent cuts at the base, center, and top sections of the post, we used an OG bit with a 1/4 inch radius. Two bits are used to create perfect dovetails. A 1/2 inch diameter 2-flute spiral bit mills a chip relief slot, and the 3/4 inch 14-degree dovetail bit finishes the job. The first step during setup was to cut the material to length and attach the indexing and quick release hubs. We put one of the screws in the center of the index hub, which gave us a pilot hole with a dowel screw. This kept the 2 sections perfectly aligned when assembled. The second step was to change the standard fences to the spiral drive fences, and then add the gear drive system. A retaining clip held the index pin in the disengaged position. We chose the 45-tooth gear, which gave us a 4-inch per revolution pitch. We also replaced the index gear with the optional index shaft handle, which made the stock removal and sizing easier. We cut 2 blocks of equal size and placed one under each end of the woodchuck. This is a quick and easy way to set the bed perfectly level. For stock removal, we used the dish cutting surface planer bit shown previously and rotated the stock using the optional index shaft handle. Watch how fast the chips pile up. The depth of the cut you make will depend upon the size and horsepower of your router and the wood you select for your project. You'll be pleasantly surprised by the repeatability and accuracy that you will achieve. We adjusted the tailstock to accommodate the shorter piece of stock and repeated the stock removal process. We made a final sizing pass on each end by rotating the index shaft while moving the router slowly along the stock. The diameter for this section was milled to 2 7/8 of an inch. Next, we laid out a 21.5 inch section for the rope molding and set the stops to limit the router travel. We milled this section to a final diameter of 2 1/4 inches. After the stock was sized, we used a taller set of blocks to raise the adjustable bed for the remainder of the project. We replaced the index handle with the index gear and engaged the drive system. We finished the spiral drive assembly and set the starting position for the rope molding. The fences need to be tight against the router base to prevent any possible chatter. We then begin milling the first of 4 separate flutes. A simple way to create a 4-start pattern is to release the tailstock and rotate the material 90 degrees. Then mill the next glute in the opposite direction. The Woodchuck spiral upgrade can make up to 12 separate starts and cut several different pitches. The flutes were not cut to the full depth on the first pass. A final cleanup pass of 1/16 of an inch was made to ensure a smooth finish that requires little sanding. This procedure may not be required. The accent cuts were milled using an OG bit and the stop set to hold the router in the desired location. Note that the index gear has been replaced by the index handle. The stops were moved 2.5 inches between each accent cut in the center section of the post. The two accent cuts at the top of the post were made 7/8 of an inch apart. Here you can see how the ends will be trimmed prior to final assembly. To mill the relief cuts for the legs and brass hooks at exactly 120-degree spacing, we replace the handle with the index gear. Note that either the 24 or the 36 position indexing plates could also have been used. The stops were used to locate and set the length of the relief cuts for both the brass hooks and the leg joints. Next, we cut the dovetail slots in the base of the post, using the bits described earlier. The final step was to cut off the excess material of the post. Note the perfect joint. We used the grid to transfer the pattern of the leg from the blueprint. This product is also available from Phantom Engineering. By using the grid, we were able to easily follow the grain of the wood. The legs were cut out and then clamped together in a vise for sanding. We cut the cheeks and shoulders of the dovetail tenons on our table saw. Then we cut a relief on the tenon for a perfect fit. A 1/4 by 2.5 inch long dowel screw was used to join the two sections of the post. Because we used the center holes from the hubs as pilot holes, the alignment was perfect. Finally, we install the legs. All that is left is sanding, choosing a finish, and mounting the brass hooks. This project videotape is just a small part of our commitment to enhance your personal satisfaction and creative freedom by providing you with quality, innovative tools, education, and continuing customer support. If you have any questions, comments, or suggestions about the project in this videotape or any of Phantom Engineering's products, please call our customer support hotline at 800-279-4570.